is this function even?
Yes.
Because f of x is equal to what?
Negative.
F of negative x. Now guys, in your notes from yesterday, we said, well, that's probably going to be symmetric about what?
The y.
Y-axis. And I have it up here. Does that look like it's symmetric about the y-axis?
Yes.
Okay, so we'll take a look at the next one here. We want to know if this function's odd or even right here. Guys, what degree is this function over here on the right? Third degree, so we probably better check to see if it's odd. Okay, we want to know, is this odd or not? So I'm wondering, well, is this odd? Well, I don't know. Okay, so I'm saying odd because the leading degree up here is 3. Take a look back on the first page of your notes. Definition of odd. What do we need to show?
F of negative x is equal to negative f of x.
Okay. I'm going to do this one on the right first, the negative f of x. This is basically saying take your function f and do everything. Do what to everything?
Negative.
Okay. So right here, if I look at the f of negative x part, this is going to equal something, and then we're going to look at negative f of x. I think we're going to do that one first. Maddie, what'd you say again? We just do what to all the signs here for this type of function?
Flip them.
Flip them. So this would be negative x to the third minus x minus 2, right?
Yeah.
Okay? That's what it would be if you flipped all the signs there. Now, if I look at f of negative x, here's what we end up with. This becomes negative x in parentheses to what power? Plus negative x, when I replace that x in the middle, plus 2. I'll make some room here, kids. Help me with that f of negative x part. What's negative x to the third going to become? What's 3 x's that are negative multiplied together going to be? Positive or negative, kids? So negative x to the third. Let's see, that plus on negative x, that's like minus x, right? And then plus 2. Ooh! Are they exactly the same function in the end? No, they're not. Therefore, can this be odd? No, this is not odd. In this case, f of negative x, in the end, did not equal negative f of x. Therefore, this is not odd. And it can't be what? Even, because it's a third degree function. Right? Now, if I looked at this graphically, kids, I'll go over here and do that quickly. But if I looked at this graphically, what's the rules about symmetry for odd functions if you look back at the first page? Symmetric about origin. Okay, so what was the function again, kids? X to the third plus x?
X plus 2.
Does it even go through the origin? Doesn't even pass through the origin. Therefore, is it going to be symmetric about the origin? And it's possible it could be, but it doesn't. No, so that didn't work, did it? Therefore, this function is neither odd nor even. You guys okay with it? Yeah.
So then, if it goes through the origin, then does that mean that
It doesn't guarantee it. It doesn't guarantee that it will. Okay, but most times it does.
So then, if it's not odd, then would you immediately be able to figure out that it's also not even, or is it?
Maybe a better way of thinking about this is, I look at this function right here. I know that this can't be what? So it might be even. So the only thing I can say about this, well, it's not odd. So it could be what?
Even.
And over here I say, it's not even, so we got to check to see if it's what?
Odd.
Makes sense?
Yeah.
Better way of thinking about that? Okay. Odd even functions. You okay on those? Understand what it is you need to show? And if you don't remember it, if you don't memorize it, check that first page of notes. Definitions of odd even. But guys, you should be able to do the work, but could you graph them first to get a good visual to know that your work is right or wrong?
Yeah.
All right, last page. Let's rock it. Ooh. Writing functions for composite functions. I like this stuff. I like this stuff.
Head, shoulders, knees, and toes, knees and toes.
It says determine functions what and what here, kids.
F of x and g of x.
Such that our function h of x, in this case, what's h of x equal to on the left? 4x plus 7. Okay. Such that h of x is equal to what?
F times g.
Okay. We're trying to find two functions, f of x and g of x. Such that.
I think g of x is x plus 7, and then f of x is 4x.
You're kind of right on.
No,
You're kind of right on there.
that's good.
Okay. And I don't know. Maybe that's exactly the right answer. I don't know. Guys, when you have to take a function that's given to you and write it as a composite function, what you're asking yourself to do is, and this is the way I like to tell kids how this works. What is happening? What's happening? All right, never mind. What's happening to x? Okay? What's happening to x? So on the one on the left, what's your function, kids? 4x plus 7. So if I said, hey, x, what's happening to you within that function?
You're getting multiplied by 4. And
You're getting multiplied by
4.
4, and you're also
And added 7.
adding 7. So one function is going to be 4 times what?
X.
And then another function is going to be x
X plus
plus
7.
7. Question becomes, which is which? Think order of operations here.
Yeah. Times in 4 goes first. So which one's first? F of x, right?
Maybe. I don't know.
Snap. A, B, C, D, E, F, F, G. Oh, snap.
4 and 7 will have to be multiplied by 4.
Oh, yeah. It's multiplied by 4 first.
You know what I think?
Is that wrong?
What if you weren't sure?
E, F,
I don't
G.
know. Just grab
Let me ask this question. We all agree that we're multiplying by 4 and adding 7, right? So if I assign 1 to be, what did you want to assign f to be first, Lake?
I think 4x.
Okay. And what do you want to assign the second one to be?
X plus 7.
Okay.
Wait,
about-
hold on.
No.
No, because that would make sense, because if you look at the f to the g of x, that means if the 4x is on the outside, you have to multiply.
Okay. I'm going to write it up over here.
Now I know how to do this.
We want to write h of x such that h of x is equal to what, kids?
4x plus 7. F. Oh.
F of g of x, right? Well, listen, regardless, we have the two operations x. We're multiplying by 4, we're adding 7. Now guess what? If you go through and do this, and say, all right, this is basically like saying take g and throw it into what, kids? F. So if I took g right here, x plus 7, and threw it into f, wouldn't this become 4 times x plus 7, which is what?
Not what we want.
Plus 28.
Is that what we want?
No.
So if that's not what we want, what's true about the order that I have here? Are they right or are they wrong?
Wrong.
Okay, so actually f of x should be what?
X plus 7.
So let's fix this.
Done did it easy. Got him. Got yeet.
Here's how I think about this. Okay? Think about the g of x function that you have. If I take g of x and replace x up here, does it make what we had to start with? Okay? Now, the other way we had it, I said, if I take x plus 7 and throw it into 4x, that makes this. Not right. So if it's not right, what do you probably want to do after checking? Flip them around. And that's really all you need to do. Okay? I want you guys to try the next one on your own. What's happening to x, kids?
Getting added forward.
Adding 4 and then taking the...
Natural.
See what you come up with for f and g there, and then we'll put a composite together to see if that creates h of x up there again for
I
us.
done did got it. Easy money.
Oh, did I screw this last example up? Hang on. Oh, thank goodness.
weighed like 35.2 was class started. That's awesome.
Can I go back to the previous one right here? Remember what we said typically, if I read 4x plus 7, what was the first thing we would do here? Would we take 4 times x and add 7, or would we add 7 and then times 4? Times by 4. What's the inside function here, kids? Times by 4, right? Does that make sense? Typically that inside function is the first thing you would do to the function. So what two things are you doing to x up here again, kids? Natural logging x plus. So would I natural log the x, or would I add 4 to x first? So in composite functions, if we say start at the innermost part of the function, if you're saying add 4 is the first thing we're going to do, then what do you think the innermost function should be then?
X plus 1.
So in this case, f or g, the way I've set this up.
GG.
So what do you want to put for this?
G equals x plus 4
Okay, and then what do you think f of x would be?
natural log x.
So help me. If I take my function g and put it into replace x and function x, do I get the same thing?
Yep.
Absolutely. Okay.
Absolutely.
So I agree. That's how you break it down. Okay. Ask yourself what's happening. And the thing that typically happens first to the function is which one? The innermost function or outermost?
Inner.
Innermost. That's probably the best way to think about that, okay? All right. Oh, this is good stuff. I love this stuff. It's so much fun to me. Hey, we're on the last example. Can I get a yeehaw? Oh, I got one. I can't believe it. I didn't think you would do that.
Well,
All right, I'm going to teach. Kids, I like these. We're going to try one together. It says, determine values of composite functions from tables. Here I have a bunch of x values. So when I input 1, what's the output for f? If I would input 1 for g, what would the output be? So you get how to read this table. If I input 3, what's the output for g? 1. We're supposed to evaluate f of what? Okay. Well, f of g of 3, kids. Well, okay. We know composite functions say start from the inside and work your way out. We all agree there? Well, let's start with g of 3 here, guys. So go up here to x value of 3. What's g of 3 kick out? 1. So do you guys, g of 3 gets replaced with what value? So we're really evaluating f of what now?
1.
So go to 1. What's f of 1 equal?
4.
So in the end, my solution would be what?
4.
So if I was graphing the function f of g of 3, that point would be 3 comma what? 4. Okay? F of g of 3 is equal to what? Right? F of g of 3 equals 4. Okay, start with this g of 3 part right here, kids.
2.
What's the x value I started with?
1,
3. So go to the x value of 3. Are you there?
yes.
Okay, what's it kick out in the g function?
1.
1. So this g of 3 part is really now the same as the part I circled right here is really what value right here. Okay, whoops. It's 1 right there. So now we're evaluating f of what? So go to an x value of 1. Evaluate your f function. What do you get in the end? Okay, you guys try these two right here. See what you end up with.
No. F of 2.
G of f of 2 and f of g of 4. Sounds like a foreign language.
Right? Right. Guess what? Chicken.
Ooh, this will be interesting. Talk with your neighbor. If you get stuck, kind of try to guide each other through it. It's kind of like driving in traffic with a backseat driver sometimes. I get it.
What is going on here? Breakfast. taking educated guesses. Mhm.
Oh, she won't. I don't get it. She had 14, we had to do 10 chapters, but she couldn't grade our stuff.
You should go like, but you had for 10 days. That's what she told on us.
She has to
Only
get
people
one.
in my class,
one.
11. She put my grades when you guys' messages went out. So she just set 3 hours as like this was now she could have fun.
All right, sounds like by the conversation we might have some solutions. So this g of f of 2, who's helping me with this one?
G3 equals 1, right?
Yeah.
Agree with that, John?
I think so, that's what I have.
John, are you willing to talk me through it, buddy?
Yeah, bro.
Okay, so f of 2,
F of 2 is what?
x is 2, so then 2 for g, which is 3.
So this becomes really the function g of what then? Whoops! Hang on a second. Let me fix this. G of what then? This is what this really becomes.
Yeah, g of 3, which then that means 1.
G of 3 then runs down to...
1.
Hey, you got it. How many had 1 there?
Yeah.
Yes. Okay. This isn't so difficult, is it?
This is fun.
Kind of fun! Oh my god, somebody said calc and fun and the same thing. Oh my gosh, made my day. Alright, who's ready to talk about the next one?
Yeah.
Maddie, you want it? What'd you get first?
1.
1? Okay, talk me.
G of 4 is 4.
Okay, so this inside part right here is 4, is that right?
Yep.
So this really becomes f of g of 4, doesn't it, kids?
Yep.
Now this is a little trickier because instead of a composite of 2 functions, we have a composite of 3 functions. All right, I'm listening, kiddo.
So then you have G of 4 again. which
So
is
g of 4, which is
4.
4 again, so this becomes f of what now?
4.
F of 4, which is equal to 1.
And f of 4 is? How you feel about that, kids?
It's a nice sheet.
Okay. Kids, questions so far on the notes right there? All right, hey, assignment-wise, did you guys all get the numbers written down yesterday?
Yep.
Do I need to write them down up here again or not?
Nope.
I believe it was page 49, is that right?
Yep.
I think it was 1, 3, 6, 9, 12 through 18,
6,
22.
22, 24, 29 through 32, 36, 38. How many of them start on that?
I've got
So?
Yeah.
All right, let me stop this recording. I'm going to get that loaded up there.